Goedemiddag, beste collega's. Heel hartelijk welkom allemaal op het voorlaatste Research at the Movies praatje van dit jaar. Ook heel hartelijk welkom aan de mensen die online volgen. Wij geven vandaag het woord aan Luna de Bruyne. Zij werkt aan een doctoraat over emotiedetectie bij Veronique Goste. En de vraagsteller vandaag is Cynthia van Ee. Dus het wordt alweer een boeiende middag. Geef heel graag het woord, alsjeblieft.
Yes, thank you. I'm going to do this talk in English, if that's okay. Thank you for the introduction. Thank you for being here, and also the people at home. I'm in the final year of my PhD, submitting in September. So when I was signing up for doing this talk, I thought of just doing an overview of everything I have been doing the last years. And that is still the plan, but the past month, actually, I have come up with a new idea, a new perspective, new angle on my research, and I'm very excited about it, and I already want to share it with you. So that will be the main angle in this talk, the fuzziness of emotions. It is a problem that I have encountered multiple times during my research, actually in every paper or every study I've been doing, and it has to do with the following. So I want you to read this tweet, and I want to know who of you think that this is a good example of someone who was tweeting this when he was afraid. So if this is a good example of fear. So who think it is? Who thinks it is? Okay, quite some people, but not so many. What about this one? Are there people who think this is fear? Yeah, still a few. Maybe some who think that this is sadness or desperation. Yeah. And what about this one? Is there anyone who thinks this is fear? Yeah, or excitement? Well, actually, people could indicate this or label this as fear in our annotation task. So, what I want to show you with this is that emotions are quite fuzzy. So sometimes it's very difficult to say to which category an instance belongs. There are some examples that are really prototypical for a certain emotion. For example, I think actually the first one was quite prototypical for fear. This one, not so much, and this one is really at the borders of the concept of fear, you could say. So that is why I am claiming that emotions are fuzzy concepts, and I'm not the only one who says that. And to back this up, we have this theory called prototype theory. It is a theory from cognitive linguistics and semantics, but it was actually introduced in psychology in the 70s by a researcher called Roche. And they put it opposite to the classical semantics or the Aristotelian semantics, where there had to be some sufficient and necessary. No, yeah, sufficient and necessary is the same. Sufficient features to be included in a certain concept. So it was actually a binary thing. Either it is a part of the concept or it isn't. But now in prototype theory, one could say that there are some prototypical examples in a category, and others could be partly member of it. There's kind of graded membership. So let's take the example of a bird. A robin, for example, is a prototypical example of a bird. A chicken, not so much. Penguin is also not so prototypical for a bird. And then you have these weird instances or weird figures like the platypus, for example. You can't say that this is a bird, but it has some features that also are shared with birds. So in the center you have the prototype, and the further you go away from the center, the less prototypical it is. So this is graded membership, what they call. And then at the edges, these are what they call fuzzy. So all the instances at the border are quite hard to classify in one of those categories. And I also claim that these boundaries are not static, they are dynamic, so they depend on the context, on the domain. So these boundaries, they can shrink, they can increase, there can be certain bulges, really depending on the domain. So this is the bird example, but same goes for emotion categories. So yeah, I thought this was quite an exciting angle to view my research from. So now I will give a bit of background and discuss some papers I have written with this angle as a viewpoint. So I'm working on emotion detection. So automatically detecting emotions in Dutch text. So that is why the project is called Emotional. Took me 3 years to come up with this name. So as in many NLP problems, or in many NLP tasks, there are two main problems or two main issues in NLP, machine learning, and that is data collection and generalizability. Same goes for emotion detection. So generalizability across frameworks. So do we want the typical emotion labels like joy, surprise, fear, or do we want some other labels? If you have a model for the one, you can't just use it in another task with other labels. Other domains is also a problem, and also other languages. So when I started my PhD, there was this new concept coming up called transfer learning. And it was quite promising. So I thought with these transfer learning methodologies, I could solve all of these problems by cross-lingual, cross-framework, and cross-domain transfer learning, which was, of course, not the case. And that is partly due to this fuzziness of the emotion concepts, which I will show you. So the first part of my PhD project was to collect a corpus, collect data, determine a good annotation method to annotate this data, and then the annotation itself. Then make a system with these transfer learning methodologies, so cross-lingual, cross-framework, and cross-domain, and then validate the method on a use case, and that would be crisis communication. So for the first part, the corpus, I collected two kinds of data. Tweets, 1,000 tweets and 1,000 captions from reality TV shows. And we annotated them both with emotion categories and emotional dimensions. So most people, when they think about emotions, they think about the basic 6 or Plutchik emotions, which is really categories like joy, anger, sadness, fear, disgust. Surprise is also one of them. But you also have a dimensional model, and in this model, every emotion category is seen as a point in a 3-dimensional space with the 3 dimensions valence, which is positive, negative, arousal, so the degree of excitement, you could say, and then dominance, so how much in control you are. So for the first part, we wanted to annotate the data with emotion categories, but we didn't just want to use Ekman or Plutchik emotions. We really wanted to have a grounded motivation, really based on the data we have to obtain this label set. And to do this, we did a cluster analysis, and we started with 25 emotions, following the emotion typology of Shaver. And what we asked was, so we had some annotators, and we asked them to annotate couple of hundred sentences, and they needed to indicate for each sentence whether each emotion was present or not. So we had 25 labels per sentence, and either it was a 0, so emotion was not present, or it was a 1, the emotion was present. And based on these labels, we did a cluster analysis, and then we found some groups, some clusters, and there was one cluster around joy, one around love, fear, anger, and sadness. So it is quite close to the Plutchik Ekman emotions, but not completely the same. But what is now most interesting, and this is where the fuzziness comes in, is that the content of these clusters depends on the domain. So we did this cluster analysis first for tweets. So you see in yellow the love cluster, then the joy cluster, anger cluster, surprise, and did I miss one? Yeah, one is, but this is probably not the correct figure. But what we do see here is, for example, that frustration and irritation are clustered together. This is a separate cluster. You can't see it very well. Nervousness is a separate cluster, and this is actually the fear cluster. So we do have 5 clusters, and it is the correct figure after all. So you see that frustration and irritation are in the anger cluster, which is logical. And surprise is clustered together with sadness and pity. But then, for example, for our subtitles or captions data, one of those reality TV shows we transcribed was Blind Getrouwd. And there we saw that frustration and irritation are in the sadness cluster, and that surprise is together with fear and nervousness, and not with, what was it here? Sadness. Here again, surprise, here it is again with sadness and not with fear. So this is to indicate that we do see the same clusters appearing, but the content of those clusters changes dependent on the domain and the topic as well. So that was it for the categorical annotation. Then we also did the dimensional annotation, and there we had several options. So we already had some indications that the normal rating scale annotation, so just saying for each instance on a Likert scale, for example, which degree of valence, arousal, and dominance was in the sentence, that there are some disadvantages with it. So there's scale bias, low inter-annotator agreement, in summary. So what we did was a study to see which was the best method to annotate those dimensions, and we compared the rating scale method, pairwise comparison, that is where you have 2 instances and you have to say which one has the highest valence, the highest dominance, highest arousal, and then also best word scaling, where you see 4 examples, and for each tuple, so this is the tuple for valence, this is one for arousal, this is for dominance. You have to say which one has the highest valence and which one the lowest, which one highest arousal, lowest arousal, and same for dominance. And then we saw that best word scaling had the highest inter-annotator agreement, but it took a lot longer to annotate. But after all, we did choose this method because it was the most reliable one. So this is an example of the data. And once we had that data, we did some experiments with it. And first we did some basic experiments. First with traditional methods like SVM, but the results for that were very low. I didn't report them here, but they were really much lower than the ones reported here. This is another surprise in my PhD, and it is the rise of the transformer models. They didn't exist when I started my PhD, so it wasn't in my plan to use them. But yeah, now everyone is using them. It is really the state of the art in NLP, so yeah, I couldn't else than use them as well. Transformer models are actually, they integrate transfer learning in their architecture because they are pre-trained on a large amount of data, so that enormous language models arise. And based on these language models, you can fine-tune them on your task, on your specific task, and they tend to perform very well. They weren't used for emotion detection in Dutch, but now they have, and this is really the best we could get. I've tried several things, but the transformers were what worked best. So that was also a bit of a reality check, because then I thought, okay, what is my role in the research then? But as you will see, I have done lots of other stuff as well. The best accuracy we could get, but still not so high. So we have 0.54 for tweets, 0.48% accuracy for captions, which is quite low. And then for the dimensions, that is not a classification task, so we can't calculate accuracy, but we can calculate Pearson's R to measure correlation. And there you see a coefficient of 0.64. So that looks more robust, but you can't really compare the numbers because it's different things. Now, when we looked at those numbers, we thought, this is not really a fair measure, because that is actually the next point. Not all mistakes are as wrong. So, for example, predicting joy instead of love is much is less wrong than predicting anger when it is love, for example. So we wanted to take this into account, and I made a metric called cost-corrected accuracy. And with this metrics, the scores are much higher. But I also think that they give a more reliable image. And how we how we measured this was, so as I said, taking into account the cost. So normally, accuracy is calculated by dividing the number of correct predictions by the number of instances. So it's the sum of the diagonal in a confusion matrix. But in cost-corrected accuracy, you take the product of the confusion matrix and a cost matrix. And you actually can define the cost numbers yourself. So what I did was cost is 0 on the diagonal because that are correct predictions. So there is no cost. If the prediction is completely wrong, then the cost is 1. So for example, predicting joy instead of anger. And what I then did was saying that predictions in the same polarity, for example, mixing up fear and sadness or fear and anger, their cost is 1/3. And when it's mixed up with neutral, then it's 2/3. So I made this cost matrix based on polarity. What you then see, if all mistakes would have cost 1 in this cost matrix, then cost-corrected accuracy is equal to normal accuracy. And if there's no misclassifications, then there's no cost. So then the cost-corrected accuracy is 1. Okay, so that was it for the basic part. I don't know how much time we still have. Okay, not so much. So I will very quickly go through the last slides. So these are the actually interesting experiments about cross-domain. What we saw there was that when you make a model on the tweets data and you test it on the captions data and the other way around, then accuracy goes down, which is logical. But yeah, this is again a proof of this fuzziness that you can't just go from one domain to the other because the content of those labels will change. Then for cross-framework, we found something very interesting, and that is that if we use the predictions from VAD, from valence, arousal, dominance, then it can help the performance of the categorization of the classification experiments. So again, we see classification is not so accurate because of this fuzziness, but it can be helped with the dimensional models. And then cross-lingual transfer, that is still some work in progress, but again, we see here that we have this fuzziness, that not all lexical concepts are the same across languages. You also see that here in another study that was performed it was co-lexicalization experiments. And for example, you see in Indo-European languages that fear is close to anxiety, but in other languages, for example, in Austro-Asiatic languages, anxiety is close to regret. Yeah, then for validation, I did some experiments. It's also work in progress on crisis communication. And again, something I saw here was that actually love was quite present in the data set, contrary to the data sets we had before. But actually, it's more like compassion. And that's also the reason why it is often confused with sadness. So here, actually, the polarity is not valid. So again, another different boundary for this concept. So my conclusion is that the content of emotion concepts varies over domains and languages. That's why I say that emotion concepts are fuzzy. That's also why there is a low inter-annotator agreement and why machine learning models not always perform that well. I do have some possibilities to deal with this, and that is the cost-corrected accuracy that gives a more fair measure. And also the dimensional models can really help in predicting classes, but also as just another way to look at those emotions. Yes, that was it.
Hi, Luna. First of all, I want to tell you that I am very impressed by what you are doing. You are creating new accuracies. You are finding clever ways to annotate your data with the captions. I will ask something about it later.
Yeah.
But I first would like to ask you something about the idea that you want to use emotion classification cross-domain, because you said that it's very difficult because what's inside the emotion categories differs between domains.
Mm-hmm.
So my question was, how do you, when you are training a model to recognize specific emotions in a particular domain, and you try to port that model to another domain, what is it exactly that you are classifying then? Is it the same way of expressing emotion, but with another label, or
Yeah, so we are looking for the same labels, but probably the content of those labels is different. So you are looking for different things. These transfer learning methodologies can help, but you always need some training data in the target domain as well. And then these transformer models can go from one domain to another quite quickly, and they can adapt to that. But if you really want one model and use it on another domain without any training data, then that gives problems, as you also saw it was very quickly. But the performance drops quite a bit. What you can do is try to make domain agnostic models. I have experimented with that, but it wasn't a great success. But in theory, it should work. By using what they call adversarial training. And there you actually train two tasks at the same time. So one task is emotion detection, and the other one is domain detection. So you get instances from two domains, and one classifier needs to decide from which domain the data comes. But actually you want this task to perform as bad as possible, while keeping the emotion classification as high as possible. And if that would work, then you would have a domain agnostic model. The performance will not be as high as a model where the domain information is present, but it is more generalizable than a model where the domain information is kept intact.
Yes, I understand. And do you have any idea of the features that are relevant then in that kind of situation, or is it too much black box?
It is black box. But the idea is what actually happens is that these features are deleted, removed from the model. Mm-hmm. It's normal that the model will perform worse, but you can't really know what these features are. Mm-hmm. Yeah, there are now a lot of people working on explainable AI, but it's still not really there. So
okay. I was also wondering about the fuzziness of your emotions, as you explained to us. My feeling is, for instance, with the emotion love, that it's very difficult to distinguish from compassion or the excitement of being actually in love, and it can also depend very much on the domain in which you are training. And I was just wondering, how do you make use of dimensions such as the VID example that you gave to try to distinguish between actually being in love and more a feeling of compassion? Because in one domain you would not find the emotion of love would not be equal to being in love, whereas in other domains it would be.
Exactly. It's actually two different concepts.
Yeah.
But in our annotation guidelines, we just see them as one. So when it is compassion or when it is being in love, the label would be love. And actually I didn't think that so many compassion instances would be present, because in the data set I had, it wasn't that present. Also in our cluster experiments, love was actually always a positive emotion, but it's now that I'm dealing with this crisis communication data, where there's also, it's not only corporate crisis, but also natural disasters and health crisis. And there you really see this concept or this emotion of sympathy, compassion, where it has a more negative, or used in more negative concepts as well. That's difficult to deal with. And that's also, well, actually, I would have thought that love, therefore, would not be easy to predict, but actually the model does quite well on love. Well, actually does very well on love in that crisis communication data. So even so we have actually measured different things, labeled different things, but still the model is capable of detecting it. Okay.
Yeah, I asked because we did for the news DNA project, we did some similar experiments on news data as well, and we saw that from the moment there's some compassion in it, the model is often confused because compassion can be a good thing. It can be lexicalized with positive words, but it can also be very sad. So I was just wondering how.
Yeah, that's this fuzziness.
Yeah. I also had a question about the cost corrected accuracy, because you said that you placed the emotions on a scale based on their polarity.
Yeah.
So anger and sadness was on the same side of the scale, whereas love and joy would be on the other side.
Yeah.
I was just wondering, is it something task independent? Because for some tasks, for instance, it would be you may want to have a high cost to distinguish between anger and sadness.
Yeah, you can adjust those costs yourself. So I showed you the cost matrix.
Mm-hmm.
You can put in what number you want to be on. Well, if it's between 0 and 1, then the calculation will add up in the end.
Okay.
Yeah.
So
but you can adapt it if you want. If you want a higher cost for example, do you have a concrete example of where you want?
Well, if I think about, for instance, cyberbullying detection, where you would use emotion labels to distinguish between cyberbully, the people who are involved in cyberbullying, then you would associate anger typically with a bully and sadness with a victim.
Exactly,
So in that case, I think it would be important that they are both on the other side of the scale.
Yeah. Then you can.
But that's possible.
Yeah.
Okay.
Yeah.
Cool. Nice. Okay. Maybe one more thing that I thought it was very clever of you to work with captions as data, because annotating sentiment and emotions is very difficult. So with captions you have the image, you may also have sound and music that can help you to indicate which emotion is being expressed. And I was just wondering, does it help the classification as well, or just does it only give better annotations?
I didn't really measure it, so we didn't compare with having the image and not having the image. There was a master thesis written about it, but I forgot the conclusion. But in my thesis, we didn't really measure it, but we do see that the inter-annotator agreement is higher, much higher actually for most of the categories for captions compared to tweets. Because there is more context, because they have the image and the sound, and it was also the same people who transcribed the series that annotated the data, so they knew what was the content about.
And did you choose the reality TV genre on purpose?
Yes, because we wanted spontaneous speech and not scripted speech.
Because I would also think if it is scripted, people have thought about how to express an emotion, but that's exactly the opposite of what you want. Okay. And do you think it's something interesting for other tasks as well? Because I don't think I've read it in many papers so far. Working with
I think it is. I would think it's much easier to annotate than, for example, tweets, because tweets, they are so short and it's really difficult to grasp the context. So in that sense, it's very interesting and useful. But you have to make some decisions. For example, what do you do with colloquial speech? Do you write it? Do you standardize it, normalize it, or do you keep it like that? We didn't. So we kept dialect words, and and that's also why it is quite difficult for the model. Because even though inter-annotator agreement was higher, the performance of the classifier was lower on captions.
Because of that, among other things.
I think so,
Okay. Okay. Yes. I think I'm done with my my questions. Thank you once again.
Thank you.
Oké, super. Daarmee is het officiële gedeelte van deze research at the movies gedaan. Maar we weten dat we allemaal nog even mogen blijven nakaarten en dat er nu vragen uit het publiek mogen komen. De toehoorders die online hebben gevolgd, heel hartelijk dank voor jullie aanwezigheid. En voor de rest, voel je vrij om een vraag te stellen.
Yes.
Thank you, Luna. I think this is a very interesting topic and it was a very interesting presentation, so thanks a lot. As you know, I'm interested in crisis communication. One thing I was wondering during your presentation was for organizations in crisis or for governments addressing crises, it's first and foremost interesting to be able to grasp what emotions prevail on social media. But another thing that's interesting is to know what those emotions or who those emotions are directed at.
Yeah.
An example that I was thinking of was the Voice of Holland, for instance. So this Me Too case in the Netherlands. I think for Endemol Productions, the production company, it would be, to determine their response, it would be interesting to know is anger the prevailing emotion? And if so, is the anger directed at Marco Borsato and the others, or is it directed at John de Mol?
Yeah.
Because that will strongly determine what your response should look like.
Yes.
So are you able to do that?
It's funny that you say that because actually I have collected data on the Voice of Holland and I'm working with that now. And you do see indeed that it is very difficult. Well, there are joyful emotions, anger, yeah, all kinds of emotions, but we don't have the information about who the emotions are directed to. So now we just look at hashtags. So we collected data based on hashtag the Voice of Holland. So we think, okay, it is about the Voice of Holland. What you could do is filter and look for keywords like John de Mol or Marco Borsato, and then you know what the target is. There are some more advanced techniques. You see that also in sentiment analysis, aspect-based sentiment analysis. And now also in LT3 they are working on aspect-based emotion analysis. So it is possible, but I didn't do that for my research. But I do think that you should do it because now, yeah, we have this data set with a lot of emotions, but we don't know who they are directed to. So yeah, you should.
Okay, thanks.
Take
Interesting.
it into account.
Yes, thank you very much. I'm very interested in the fuzziness concept, and also of the cognitive linguistics. Yeah, really, because if you come from the linguistics, sometimes in typical NLP classification tasks, we all think there is something like cognitive linguistics between the 70s and now. Now, is there a way of integrating fuzziness in your training data? I think that mainly fuzziness, you use it to explain probably classification errors, mistakes. But in the training data, are examples classified also as more or less fuzzy or more or less prototypical for a specific
I actually
category?
think that would be a good idea. So instead of just putting a label on a sentence, you could have a label and its intensity or its membership to that label. And I think, that would be very interesting. Yeah.
Perhaps
Also, because I am just working with the state-of-the-art transformer models, but there's another colleague also in LT3 working with fuzzy rough set techniques, and that comes actually from the idea of from fuzzy logic, which is a translation of this theory in logic, and then there's an algorithm. And she uses that, but I don't know much of that.
Right.
But so you can integrate it in the training data, also in the algorithms you use. So it's really at all levels that you can use this concept of fuzzy concepts.
Okay, thank you.
Yeah. So. Yeah, and
fuzzy logic, it's not 0 or 1, but it's a value between 0 and 1. To which degree it belongs to the category.
Yeah. And that's exactly also what you could do in the training data. So not just it is anger or it's not anger, but also it's degree of truth, is it called in fuzzy logic?
And could interannotator agreement or disagreement play a role in that? Because, well, now more or less we see disagreement more or less as a negative thing. You want them to agree. But if there are...
Actually, there's a very interesting paper on it. And they investigated what the link was between emotion intensity, which you maybe could see as membership of the category, inter-annotator agreement, and confidence on the annotation. And they saw that they were really entangled. So if your confidence was low, then you would rate the intensity low. Or if the intensity was low, your confidence would be lower, and then inter-annotator agreement would be lower.
Thank you.
It's maybe a basic question. I was wondering whether you and the other researchers in corpus linguistics, whether you always use the 6 basic emotions or whether you use other frameworks. I'm thinking, for example, about Martin and White's framework. They do not use these 6 basic emotions, but they use a framework comprising satisfaction, dissatisfaction, security, insecurity, inclination, disinclination, and so forth. So is it always established, these 6 basic emotions, or is it...
No. Not necessarily, but most studies do use either Ekman 6 or Plutchik's 8. And then you have some dimensional models, but that always mostly is valence, arousal, dominance, or just valence and arousal. But the model you mentioned, I haven't seen that in NLP studies for emotion detection before, but it's not a rule that you have to use Ekman 6 or Plutchik 8. But of course, if you do, then it's easy. Well, then you have a benchmark or models that you can easily borrow. Yeah. But it's not a given that it has to be Plutchik's 8 or Ekman 6.
Yeah, maybe I can comment. It's also a question of having enough data. So Luna also started with Shaver, but there you have 20, 25, 20. Mm-hmm. But the problem is if you only have very little training data, you can't base your model on anything. So you have a very low accuracy, and then it's better to combine similar emotions and have a good system for that instead of having a too fine-grained system for which you don't have any data. So it's really a trade-off between having enough specificity in your emotions and having enough data. I have another question, Luna. So your cost-corrected accuracy doesn't bring you to 100%?
No.
So what would bring you to 100%? So what are the type of errors you see currently still in the data, and what do you see as possibilities for a postdoc to tackle this issue of complete emotion detection?
It will remain an issue because even humans can't agree. But it's also a bit of the problem with the data. So especially in tweets, although I have to say that we cheated a bit because we only used tweets that contained emojis. But even then accuracy was low, so it's still difficult. But the context is so scarce that it's just so difficult to come to agreement even between humans, because the performance of the model isn't that much lower than the agreement between persons. So you can't. I think that the limit is the human agreement, and that is not close to 100%. So I don't think we can get there. But postdoc-wise, I think the issue of cross-lingual emotions is very interesting. So now I'm just doing a very short study on that, but I think that is something actually to see how the models that we are using now in NLP, how much language-specific information they need. So as I said, humans don't agree, but humans do need some knowledge about the context domain, but also about the language and language codes and cultural codes. For example, in cultures where there's a lot of sarcasm, irony, you have to know that to correctly judge the emotion of someone. And I want to know whether NLP models use this information as well, and how we can integrate that information in them. But that is something for the future.